Hello everyone, this video I will introduce IRR. The full name is internal rate of return. So internal rate of return is that we first the present value of inflows equals to the present value of the outflows. Basically means that there's a discount rate, which is the internal rate of return, makes the present value equals to 0. Net present value equals to 0. So basically means the cost, the present value of the cost equals to the present value of inflows. And what makes those two equals? That's a discount rate, internal rate of return. So it's more like the yield to maturity of the bond, because remember the yield to maturity makes the price of the bond equals to the present value of future cash flows of the bond. So the decision rules is that we accept the project if IRR is greater than the required return. So here, the discount rate is IRR, and then we assume that for IRR rules, the cash flows are reinvested at IRR. Remember, for NPV, we assume that cash flows are reinvested at weighted average cost of capital. So what does that mean, actually, this reinvestment? So for IRR, if we write here, it equals to the initial cost plus the present value of first cash flow, and keep going, present value of the last cash flow n. And the present value, we can rewrite this in formulas. It's cash flow 1, we discount it by IRR. And the second cash flow, we discount it by 1 plus IRR to the power of 2, and keep going. To the power of n. Here it means once we receive cash flow 1 at t equal to 1, we will reinvest this cash flow 1 into projects with a return of IRR. This formula basically means once we receive each of those cash flows will be reinvested in projects with a return of IRR. For NPV, we assume once we receive those cash flows, we reinvested in a project with a return of weighted average cost of capital. That is the reinvestment assumption. So let's calculate the IRR for project L. I just put the formula, the financial calculator procedure here. And I will share you this. So for IRR, the cash flow here, we clear all the previous cash flow. Second is easy. For project L, the initial cost is $100. At year 1, we receive $10. Year 2, we receive $60. And year 3, we receive $80. Enter, and after we enter all the cash flows, what we will do is we press IRR and compute. So the IRR of project L is 18.13. Of course, we can calculate the IRR for project S. We also clear all the previous work. For project S, first cash flow is negative 100. Initial investment is negative 100. First cash flow is 70. second is 50, and then the third is 20. And then we press IRR compute. So S has higher IRR than project L. I also put the project S IRR procedure here, and you can get a brief idea what's going on, how to use a financial calculator to calculate IRR. So the IRR rules make decision rules looks like this. When IRR greater than weighted average cost of capital, we should accept it, which means the return is higher than the cost. So remember the risk return trade-off. So here, those are weighted average cost of capital is higher, which means the required return is higher. And if IRR is greater than the corresponding weighted average cost of capital, which means there's returns left over to boost the shareholders' return. It's a good investment. If IRR greater than weighted average cost of capital, we accept the project. If IRR is less than weighted average cost of capital, we reject the project. If they are independent, we accept both because both projects IRR are greater than 10%. If the projects are mutually exclusive, we only accept the one with the highest IRR. So for independent projects, NPV and IRR always lead to the same accept or reject decision. We do not need to worry about them. Those two rules are always agree with each other. So sometimes for the mutually exclusive projects, they have conflicted decisions. We will talk about that situation later. So again, as I mentioned, IRR is similar to a bond's yield to maturity. Because for IRR, it makes the project's net present value equals to 0, which means present value of cost equals to present value of future cash flow. For bond, the yield to maturity makes bond price equals to the present summation of present value of future cash flows of the bond. So suppose here is a 10-year bond with 9% annual coupon and 1,000 par value. The price is 1,134.2. So we solve this IRR of this bond. The payment, because it's annual coupon bond, the payment will be this coupon rate times par value divided by 1 is $90 per year. So the timeline looks like this. At t equal to 0, you'll have to pay the price. Then you'll receive $90 each year, and at the end of year 10, you will receive your last $90 and 1,000 principal. So here is the financial calculator procedure. And again, I will use the financial calculator procedure. I will use financial calculator here to show how could we use it. How could we calculate IRR? So the initial investment is 1,134.2 negative. And we have $990. We have $990. So the frequency of first cash flow is 9. And the second one is 1,090, and we only have 1,090. We press IRR compute. So IRR equals to 7.08%. And the yield to maturity of the bond looks like this. I will switch back. If we calculate the yield to maturity, we have a 10-year bond. The interest rate or yield to maturity is what we need to calculate. The present value is 1,134.2 and it's negative. Payment is 90. Future value is 1,000. And compute. we found it's exactly equals to IRR. And for the let's back to the decision between IRR and NPV. So here is the independent project L. When the weighted average cost of capital is less than 18.1, which is IRR, we should accept it because IRR is greater than the weighted average cost of capital. In the meantime, the NPV is greater than 0. So both rules agrees with each other and shows that we should accept the project. If weighted average cost of capital is greater than IRR, we should, according to IRR, we should reject it. In the meantime, NPV of project L is also less than 0, and we should reject it according to NPV rules. So those two rules agree with each other again. However, for the mutually exclusive project, it's kind of tricky. The IRR for project S is here. This is IRR S. This is when the NPV equals to 0. This is the IRR of project L. And we know IRR S is greater than IRR of project L always, right? This is a crossover point for those two projects. The rate to make those two projects has exactly same net present value is 7.8%. When weighted average cost of capital is less than this crossover point, IRRS, of course, is greater than IRR of L. In the meantime, NPVS is less than NPVL. So those two, for IRR rules, we should accept S. But for NPV rules, we should accept L. So those two rules has conflict decisions. When the weighted average cost of capital is greater than 8.7, which is a crossover point, IRR rules suggest that we should accept S. And for NPV rules, we found that S has a higher NPV than L, so we should accept S too. In this case, those two agree with each other. So our conclusion here is that NPV and IRR are not always lead to the same accepted rejected decision for mutually exclusive project. And then we know that when the weighted average cost of capital is less than the crossover point, there is a conflict between those two rules. How could we find out this crossover point? Remember the difference between cash flows on this table? This is how we find out the crossover point. The crossover point, first find out the difference of cash flows, then find out the IRR of this difference of cash flows. And the IRR you find is a crossover rate. So I put the financial calculator procedure here, and I switch to the financial calculator. So again, we press cash flows and clear all the previous work. The cash flow difference for our project, for project L and S, at t equal to 0 is 0. The reason is that the initial costs are equal to each other. So the difference is 0. The first year, the difference is -60. We only have one -60. The second year, the difference is 10. We only have one 10. And the third year, the difference is 60. And after we only have one 60. After we input all the cash flows, the difference of cash flows, we press IRR compute. We found out is 8.68% or around 8.7%. That's a crossover point. So if the projects are independent, those two methods always lead to the same accept and reject decision. If the projects are mutually exclusive, if weighted average cost of capital is greater than crossover rate, the method leads to the same decision and there's no conflict. If weighted average cost of capital is less than the crossover point, the method leads to different accept and reject decisions. Here we should go with NPV rules because again it has better reinvestment rate assumptions. The so-called reinvestment rate assumptions, NPV method assumes that cash flow are reinvested at a weighted average cost of capital, as I mentioned before. IRR rules assumes that cash flows are reinvested at IRR. For the firm, majority of the project in the firm has a return of weighted average cost of capital. But IRR is project specific, so each project has different IRR. So in this case, assumes that cash flow are reinvested at the cost of capital is more realistic. So NPV rules is the best. And whenever there's a conflict between NPV rules and IRR rules, we will go for NPV rules. Some questions related to IRR. Does IRR rules account for the time value of money? Yes. We also discount cash flows to today's value. The only difference is that the discount rate is IRR. Does IRR rules account for risk of the cash flows? Yes. The risk is IRR here. IRR rules provide an indication about increase in value? Yes. If IRR is greater than weighted average cost of capital, there is an addition to firm's wealth or shareholders' wealth. Should we consider IRR rules for our primary decision criteria? Yes. But again, if the IRR rules agrees with NPV rules, that's fine. But IRR rules conflict with NPV rules, we go for NPV rules.